Everyone. It's been a while. Um, I just took a little break, so now I'm back. I feel like I want to learn more C, so let's do it. Let's continue on with the book. Okay, so data structures and dynamic memory. Building bridges. I heard that Ted left Judy on the heap. Oh, that's so sad. Sometimes a single struct is simply not enough. To model complex data requirements, you often need to link structs together. In this chapter, you'll see how to use struct pointers to connect custom data types into large, complex data structures. You'll explore key principles in creating linked lists, and you'll also see how to make your data structures cope with flexible amounts of data by dynamically allocating memory on the heap. So, another area of memory that we yet to have used, but now we will. And then freeing it when you're done. And if good housekeeping becomes tricky, you'll also learn how Valgrind can help, which is a tool to detect like memory leaks, meaning that if you forget to free memory somewhere and you forgot where, you can actually use Valgrind to kind of track and figure out where this piece of data is in memory to free up. So, do you need flexible storage? You've looked at the different kinds of data that you can store in C, and you've also seen how you can store multiple pieces of data in an array. But sometimes you need to be a little more flexible. Imagine you're running a travel company that arranges flying tours through the islands. Each tour contains a sequence of short flights from one island to the next. For each of those islands, you will need to record a few pieces of information, such as the name of the island and the hours that its airport is open. So, how would you record that? You could create a struct to represent a single island. Okay, so this is a single island. An island has a name, right? And it also has whether or not, I guess, it's open, is opened, or maybe like whether or not uh, what time, right? It opens, maybe, I don't know. And then closes. Okay, I wonder why they're even character pointers, but let's keep moving on. Now, if a tour passes through a sequence of islands, that means you'll need to record a list of islands, and you can do that with an array of islands, right? So you have four islands, so you'll have an array of four islands basically, and this island refers back to the struct type. Okay, so there's four struct objects in here at most. So there's a problem. Arrays are fixed length, which means that they're not very flexible. You can use one if you know exactly how long a tour will be. But what if you need to change the tour? What if you want to add an extra destination to the middle of the tour? So that means you need to now have an array of five islands, but then now you have to like kind of slice and insert it in between. So that's interesting. To store a flexible amount of data, you need something more extensible than an array. You need a linked list. So linked lists. Linked lists are like chains of data. A linked list is an example of an abstract data structure. So it's a concept. A linked list is a concept. It's called an abstract data structure because a linked list is general. It can be used to store a lot of different kinds of data. So there's like two aspects to it, right? So like the linked list is the concept, but then you have to build that out in code. You have to implement a linked list. So when we talk about ADTs, abstract data structures, we're just talking about like the the concept of it. And as a software developer, we have to take these concepts and translate it into code so that we can actually use it. So a linked list is something that's not built into C right now, right? We have to take these ideas of what makes up a linked list and create it ourselves. So that's sort of the preview, I guess, of what they're trying to say here. So to understand how linked list works, think back to our tour company. A linked list stores a piece of data and a link to another piece of data. Okay, so in a linked list, as long as you know where the list starts, you can travel along the list of links from one piece of data to the next until you reach the end of the list. Using a pencil, change the list so that the tour includes a trip to Skull Island between Craggy Island and Isla Nublar. Okay, so what we want to do here is we just want to repoint, I guess. I guess we want to just repoint Craggy to to point to Skull. Skull point to Isla Nublar, and then Nublar to Shutter Island. That's a movie, I think. So Amity to Craggy, Craggy to Skull, Skull to Isla Nublar, and then Isla Nublar to Shutter. So that's basically it right here. So yeah, so that's basically a linked list, right? It's like a flexible data structure that allows you to, instead of having everything contiguous in an array, you'll have basically objects here that point from one to another. So linked list allows, linked list allows inserts. With just a few changes, you are able to add an extra step to the tour. That's another advantage. The linked lists have over, that's the advantage the linked lists have over arrays. Inserting data is very quick. If you wanted to insert a value into the middle of an array, you would have to shuffle all the pieces of data that follow it one by one. So here's an example. So Amity, Craggy, Isla Nublar, and then Shutter, right? Um, Basically, since we only have 4 items in our array, so when we want to insert Skull Island, basically we had to shift Isla Nublar down 1, which gets rid of Shutter because it's exceeding the size of the array, and then stick in Skull in between. So it looks something like this. So you start out with 4 items, right? A, B, C, D. And now you want to insert E between B and C. Or it's actually C and D. Mm-hmm. Okay? But what ends up happening, right, is that in order to do that, you only have 4 elements in your array. You would definitely have to shift everything 1 over after C, right? And insert E here. But since you only have 4 elements in your array, this gets cut off. So that's a disadvantage of an array. You can't really, when your array is full, you can't really adjust it easily to insert elements in between if there are no gaps. To solve that problem here, you have to actually create a new array that has 5 elements and then copy each element in to the new array, and then E will go here and have it fit in the new array. And that can be very expensive in terms of CPU and even memory too, because you have to create 2 copies of an array now. One that is bigger to hold the size than the original array, right? So it's not very flexible. And this is actually like a loop, so it's inconvenient too. So linked lists allows you to do something different. But basically, each element here is connected to each other through a pointer from one to the other sequentially, right? So if I wanted to insert E, what I would just have to do is break the link between C and D, have it point from C to E, and then set E to point to D. So if I rewrite all this, I go A, B, C, E, D, it just looks like this. A, B, C, E, and D. Okay? Now the trick is that we know this is a linked list, right? So it's a linked list. That's the concept. But the challenge here is how do we actually implement this in code? How do we turn this model of thinking into code? And that's the basis of this chapter. Yeah. So how do you create a linked list in C? Create a recursive structure. Each one of the structs in the list will need to connect to the one next to it. A struct that contains a link to another struct of the same type is called a recursive structure. So this is a recursive structure. You have like a element here of your collection, right? Your linked list is called island, but inside that island struct, you also have a pointer to another island. So that's what makes it recursive. So within yourself, you have you as a human, you have a pointer or like a reference to another human. That human has another reference to another human. So you should just keep going until you hit a human that doesn't have a reference to another person. So I know it's a bad example, but anyway, recursive structures contain pointers to other. This is annoying. Recursive structures contain pointers to other structures of the same type. So if you have a flight schedule for the list of islands that you're going to visit, you can use a recursive structure for each island. Let's look at how that works in more detail. So notice how we have a struct here that represents an island, right? So we'll have a name and it opens. Oh, it's a time, 9 a.m., 5 p.m. Okay, opens and closes. But the interesting part of the struct is that it also has a recursive reference to another island called next. And that is basically the arrow right here, right? So if we take a look at a linked list that has, for example, numbers, 1, maybe 4, and maybe that points to 5, right? Basically, that struct just has an int. So we'll just say this is a linked list element. Is a struct as an element type. So I don't know, type def struct right here, right? So we'll have int value, and that could be 1, 4, 5, etc. And then you'll also have, in this case, a struct that is also an element that is a pointer called next, pointing to the next element of that list. So this is like an element. This struct here is one of these, right? But in each one of these structs here, not only do you have the value in here, okay, you don't not only have that value, but you also have a pointer that points to another element type. So a pointer here that points to another element type. Okay, so that's like a basic structure of a linked list. A linked list is just a composition of all these individual structs chained together. So that's what it is, right? So this, oops, this here is a linked list element. Now you take this on its own, you connect it to other elements, and you form a chain of elements, and that is basically all of this is your linked list. Okay? It's made up of these structs here, and we call them nodes, we call them elements. There's many ways to call them. Alrighty. So, yeah, the most important part is that we store a pointer to the next island in the struct. So how do you store a link from one struct to the next? With a pointer, yes. That way, the island data will contain the address of the next island that we're going to visit. So whenever our code is at one island, it will always be able to hop over to the next island. But watch it. Recursive structures need names. If you use typedef, right, you can normally skip giving a struct a proper name. So you can just say island X, island Y, island Z if you had defined your struct to use typedef. But in a recursive structure, you need to include a pointer to the same type. The C syntax won't let you use the typedef alias, so you need to give it the struct, right? A proper name. That's why struct here is called struct island. So never mind about this right now. Just know that you do typedef struct island, give this an alias of island, you still have to say struct alias in here, whatever your label is still. I think they'll explain it somewhere, but just remember you have to say struct island instead of island, or struct element instead of element, which I did right here. So okay, so let's write some code. It says let's write some code. So let's do that. Let's create a directory. Clear this. I was working on Webby earlier, but didn't come out to anything because I got distracted. So I'll do make dir linked list, and then actually I'll just do it here. So I'll make a linked list, and then I'll just make a main.c. Okay, and then I'll just do include stdio.h int main int argc character pointer argv array, and return 0. So let's actually define our island up here. Typedef struct island. Island is our alias. Then we'll give it some properties. Okay, and then we'll finally have the pointer to the next struct. So this is a pointer to an island struct, right? So we had pointer to ints, pointers to float, pointers to characters. This is a pointer to an island that references conceptually the next island in the hop, right? In the list. Okay. So what did they do here? They just defined a set of islands. Okay. So type it out just for exercise. So island Amity. So we'll create the struct this way. Name is going to be Amity. Opens is going to be 0900 9 a.m. Closes is going to be 17 o'clock, which is I think 5 o'clock. And then we have next is going to be assigned to null. So it's going to be pointing nowhere for now. So it's like a single element, right? So at this point, you know, if we were to think about this as its own list, Amity, right? It's looking to be like this. Why is it's looking to be like Amity 0900 1700, and then pointing to null. Okay? If you really, really want to make it look like it's in memory, we'll have this whole region dedicated to the struct, right? So, you know, we'll have maybe this one here, which is basically the name. We'll have that point down here somewhere in memory that just says Amity, right? And then since the struct is, these are all pointers, There's 4 properties, right? Struct island. We'll have maybe opens, maybe points up somewhere here in memory that has 0900, and then closes, which is another pointer, maybe conveniently is here. And then, potentially, in this case, the next island, is it called island? Is it next? Let's see. Yeah, next, right? Next actually points to nowhere land. Okay? So, basically what's going to happen is that if we want Amity to point to something, to another island, we actually have to point this to the start of another struct. And that's how we can keep moving forward, right? But for now, this next here points to nowhere, so which is null. So that's what we have right now. And then we're just going to create another island, craggy, another struct that is. Dot name is going to be craggy. Dot opens is going to be 9 a.m. Then dot closes is going to be 17 o'clock. And then finally next is going to be null. Okay, just one moment. Hmm. Okay. So now we have 2 nodes, right? 2 linked list nodes. They're individual. They're disconnected, right? So if we want to visualize again, we'll have. Okay, do it one more time. I keep hitting the button, this button on my pen. So we'll have Amity. Then we'll have was it 900, 1700, and then we'll have this point to nowhere. I guess it's null. And then we'll also have another one called Craggy. And that's also 9 a.m. 1700, pointing to nowhere. Okay? So 2 separate structs, and then we'll also have Isla Nubilar, which is another struct. Dot opens is gonna be 09. Okay, so 9 a.m. again. And this is gonna be 5 p.m. and then again points to nowhere. So that's our third one, right? So we've created a third one. Okay. Now, so let's draw that here. And that's Isla Nublar. Again, 9 a.m. 17, and then null. Okay? Finally, we have one more island that we have to create. Island shutter. It's a struct. Dot name is going to be shutter. And then the opening time is going to be 9 a.m. Closes time. It's going to be 5 p.m.-ish. Then it's going to point to null. Okay, draw that. Let's just draw it down here. And that'll be shutter. And then that'll be 9 17 null. Okay? Now, we have 4 elements that are all disconnected. Okay? So what do we do? Well, let's read. So did you notice that we originally set the next field in each island to null? And see, null actually has the value 0, but it's set aside specifically to set pointers to 0. So null, null, is just a special label for the value 0. So we're setting the address, right? The address of the next element, like of the next element to be 0, right? So it goes nowhere land. But now we need to link them together to form a Tor. So we're going to link Craggy, Isla Nublar, Shutter, and so on. So how do we do that? Well, that's not that hard, right? So our order is Amity, Craggy, Isla Nublar, and Shutter. Notice how that next, right? If we look at our struct definition, island next is a pointer to an island, right? So these structs here are actually values. They are values, not a pointer. This is not a pointer. This is a value, an island value, an island struct. So what we need to do is, if we want to connect Amity, next pointer, to point to Craggy, we had to actually pass in the address. We had to get the address of Craggy and set that to be the the island pointed by next of Amity, right? So get the pointer of Craggy and assign it to Amity's next pointer. So notice how they're both the same type. Next is a pointer to an island. Craggy is an island value. So you need a pointer to an island, which is why we do ampersand Craggy. So when we do that, what we're actually doing here is now we're doing this. Get the address of Craggy here, okay? I guess I'll just kind of modify it. We'll point that here. So now Amity is linked to Craggy. Okay? So now, if we write that, well, we hover over, it says, oh, next is a pointer to an island. So what we can do is we can now get the pointer to an island where Craggy is the value, right? So then now, this here is basically a pointer to an island. And we also do Craggy.next is going to be the address of Isla Nublar. So, okay. And Isla Nublar's next is going to be the pointer to Shutter, in this case. And now, if we look at it, so Craggy's next is going to be Isla Nublar. So we erase that. We set that next value to be Isla Nublar. And Isla Nublar's next is going to be Shutter. Okay? And Shutter's next is still null. So that's how the list ends, right? So we start here, and we move from Amity to Craggy, Craggy to Isla Nublar to Shutter. And then we don't have anywhere else to go after that. So that's how we actually link our nodes together. And basically that's what linked list is. It's just conceptual, right? Our list can start anywhere. We can actually start at Craggy, we can start at Isla Nublar. What matters is that we maintain a next pointer from one island to another. It just so happens that now we define Amity to most likely to be the first element of our list. But really we can start anywhere now as long as we have a pointer to that struct. What just really matters is that every single element has a next pointer so that you can get to the next place. Okay? So you have to be careful to set the next field in each island to the address of the next island. You'll use struct variables for each of these islands. So now you've created a complete island towards C, but what if you want to insert an excursion to Skull Island between Isla Nublar and Shutter Island? So we want to basically say Isla Nublar. We're going to have a stop between Isla Nublar and Shutter on Skull Island. So we basically create the Skull Island. So it's just like this. I should do it down here. So we'll have island, skull, and then it's the same thing, dot name. It's going to be skull. And then we're going to say dot opens is going to be 9 a.m. It's going to close at 17:05, basically. And then next is going to be null for now. Okay, so we'll create this element in our linked list that represents Skull Island. And what we want to do here is basically do this. Get the reference of Isla Nublar. Okay. Get the reference of Isla Nublar. Upside down pen. Erase that. Okay. Create a new one called Skull 0917. Okay. And repoint that next to Skull. Take Skull and point that next to Shutter. Okay? So now, notice we need three things here. We need Isla Nublar, we need Skull, and we need Shutter so that we can actually do this dance of references. And you'll see that in the code here, where they take Isla Nublar, point its next pointer to be the address of Skull. Remember, this is a value, so we need to get the address. So we do Isla Nublar dot next is going to be the address of Skull. Then what we want to do is Skull needs to point to somewhere, and that is going to be Shutter because it was Isla Nublar that pointed to Shutter before, but now we need to update so that Skull's next points to Shutter. So we do Skull dot next. So take the value, that struct, go to its next pointer, set that to be the address of Shutter. So now we have 1, 2, 3, 4, 5 nodes. Great. So, in just 2 lines of code, you've inserted a new value into the list. If you were using an array, you'd write a lot more code to shuffle items along the array. So now you've seen how to create and use linked lists, let's try out our new skills. Okay, so the code display function was on the fridge door, but someone mixed up the magnets. Do you think you can reassemble the code? Okay, so this here is going to want to print out your list. Okay, so let's actually create a function here, just like what they have, called void display, and it's actually taking the start of, the island you want to start out with, right? Notice how it's a pointer to an island. We don't want to pass the entire value into a function that would be too expensive. So we pass in, we pass in a pointer to the start of our linked list. And that's how we usually iterate through linked lists. We need that starting point, any node to start with. It just so happens we're going to be using Amity, but you can just use anything else. It's just that you won't be able to, move through nodes that came before that node in that structure, right? So if we say island, we start with pointer to an island at start called I. What we want to do is have a for loop. So we don't initialize anything here because, I is basically our island here. Okay, so I'm going to say, well, we want to move until what? Until I is what? Until I is null, meaning that we're no longer in a valid island, right? So that's our stopping condition. Well, I is not equal to null. And what we want to do is we want to keep reassigning our I to be our current island. So it's pretty much I, if we're here at Amity, we want to make I be Craggy next, right? So all we had to do is go I equals I, pointer, right? Next. Because I is actually a pointer to an island, it's best to use this arrow notation. Otherwise, we're going to have to do something, I think it was like dereference I and then do a dot next, for example. Like that, right? We would have to do that. But, I is a pointer, so we can use arrow notation to kind of get that dereference for free. And then we just print. Open S to S, and we'll fill this out. Our printf, we do I name, right? I arrow name because I is a pointer to an island. I opens, I closes. Okay? Then we can just call display. So we'll call display here to print out our pretty much our island starting from Amity. So how do we do that? Well, let's see. So here's the answer. So it's exactly what we thought, right? Well, I is not equal to null, and then we basically move our current I pointer until we actually hit nowhere land, right? And as we're doing that, we're accessing the properties of I, which is the island, and using the arrow notation because I is a pointer, not a value, because our function here receives a pointer, and we initialize I with that pointer. Okay. So other languages like Java have linked lists built in. Does C have any data structures? The answer is C doesn't really come with any data structures built in. You have to create them yourself, and that's true. So what if I want to use a 700th item in a long list? Do I have to start at the first item and read all of them through? Yep, that's the only way. There's no indexes in linked lists. You have to just keep moving from one place to another place to another place like 700 times, right? And he goes, that's not very good. I thought a linked list was better than an array. It's a trade-off thing, right? So you shouldn't think of data structures as being better or worse. They are either appropriate, meaning good for one thing, or bad for another thing, inappropriate for what you want to use them for. So in this case, if you want to insert things in between, right? An array is not going to be good, but a linked list is. Now, if you want to access things by index, like you don't want to you want to get maybe the 30th element or something like that, then an array is going to be good, but a linked list would not be good. So it's a trade-off. You have to think about your requirements here. So if I want a data structure that lets me insert things quickly, I need a linked list. But if I want direct access, I might use an array. Exactly. Okay. So you've shown a struct that contains a pointer to another struct. Can a struct contain a whole recursive struct inside itself? No. Why not? C needs to know the exact amount of space a struct will occupy in memory. If it allowed a full recursive copies of the same struct, then one piece of data would be different size than another. So meaning it'd rather store a pointer rather than a full size struct, because a pointer is just it's 8 bytes, right? And you can just go to that location where it's going to be the start location of that next struct. Okay, so this is the code. So we left off of how do we actually call display? Well, display takes in a pointer, right? It takes in a pointer of where we want to start. And we said we want to start with Amity. So Amity here is a struct itself too, but it is not a pointer, right, to an island. It is a value. It's an island struct, right? A completely different value. So how do we actually get the pointer to Amity and pass that in? Well, all it is remember the ampersand operator. If I do this against any value, that is actually getting the pointer. So now if we do ampersand amity, we've got the pointer to an island back. We could use that pointer to an island as an argument to our display function. So if we do that and we compile our program, oh, print f. Okay, sorry. Print f. There we go. And then here, yep, in and out. And we pretty much get the same thing, I think. Oh, I didn't put a new line, but it's okay. The gist is there. So this is basically our tour, right? We go Amity, Craggy, Island Nublar, Skull, and Shutter. And then we stop after Shutter because our island, the next island we hop to is Nowhere Land. Null, right? So yeah, excellent. The code creates a linked list of islands and you can insert items with very little work. Okay, so now you know the basics of how to work with recursive structs and lists. You can move on to the main program. You need to read the Tor data from a file that looks like this. Ooh, okay. All right, something dynamic now. Okay, the folks at the airline are still creating the file, so you won't know how long it is until runtime. Basically, this file could be like 1,000 lines long, it could be 10 lines long. You just have to be able to create these elements and insert them into lists like one by one. So how do you do that? You can't use an array because you don't know the size of this file. So it has to be a linked list. Okay, and yeah, we'll continue that next time. So I'm going to check this in. And we'll see you next time. Thanks.